Hello, Chemistry 10 and Chemistry 10H students. This is Mrs. Altman. In this video, we are going to go over how to determine if a compound is type 1, type 2, or type 3, and also how to do the nomenclature for the type 1 compounds. So before we get into the processes, I'm just going to quickly say what nomenclature is. Nomenclature is just a systematic naming of an object, so meaning that there is a step-by-step process to getting the name of something. So before we get into naming compounds, we need to break them into three different types of compounds. The little one on there on my header is just because this is going to go over 2 slides. So a binary compound consists of either 2 types of ions, for example, sodium and chlorine, or 2 types of atoms, for example, carbon and hydrogen. The type 1s, that consists of a metal from group 1, 2, or 3, so not a transition metal, and a nonmetal. These are ionic. Some examples are sodium chloride, because sodium is in group 1, aluminum sulfide, because aluminum is in group 3, and calcium oxide, because calcium is in group 2. Notice how none of those cations, the first thing, none of those are from the transition metals. That's important. Then we have our type 2, which consists of a transition metal and a nonmetal. So that is our D block. So these are also ionic, and we have iron 2 chloride. So for right now, you're probably wondering what those Roman numerals are, and that would be a good thing to wonder. We're going to get into that in the 3rd video of this chapter. But notice how it says iron, and it doesn't matter what the Roman numeral is for right now, 2 chloride, because iron is a transition metal and chlorine is a nonmetal. This is type 2. Manganese 4 oxide. Manganese, don't get that confused with magnesium. Manganese is a transition metal, and copper 2 nitrate. And then type 3 is 2 nonmetals. These are covalent compounds. Silicon dioxide. Silicon and oxygen are both nonmetals. Carbon tetrachloride. You don't need to worry about those prefixes for right now. We'll get into those, I think, the 4th video of this chapter. And iodine monofluoride. The important thing for type 3 is that it only contains nonmetals. Let's work through an example. So NaCl, because sodium is a metal from group 1 and chlorine is a nonmetal, this is type 1. And I have calcium carbonate. So because calcium is in group 2, and carbonate, you might not yet know what it is, but it is an anion. So this is also type 1. Then we have FeI3. So because iron is a transition metal, this makes this type 2. Now we have CH4. Carbon is a nonmetal, and remember the hydrogen is a weird exception, even though it's placed there on the periodic table. It is also a nonmetal, so this is type 3. And then we have carbon dioxide. So carbon is a nonmetal, and oxygen is also a nonmetal, so that makes it type 3. Now let's get into naming type 1 compounds. So when you're naming a type 1 compound, always remember the example sodium chloride. The cation is named first, hence sodium, and then the anion, chloride. The cation, we don't have to change anything, just sodium. But for the anion, you change the suffix to IDE. So instead of sodium chlorine, we have sodium chloride. Take a look at this example. Some of you are probably wondering if the subscripts and numbers at the bottom have any bearing on the name, and for type 1, it actually does not. So Be, that is beryllium, and then instead of iodine, it's iodide. And the next one, aluminum, and then sulfide. I'm typically not too picky about where you place the IDE for a test, so if a student by accident wrote sulfuride, I don't typically take up points for it unless we've, unless we've gone over it a ton of times before. And I have lithium chloride and magnesium oxide. And now let's take a look at the opposite, where you have the formula and you want the name. This is where a lot of students like to do that sort of trick with the crisscrossing in the periodic table. I'll show it for a couple here. So I've got calcium and sulfur. Because calcium is in group 2, it tends to take a charge of 2 plus. And because sulfur is in the 6th group, it takes a charge of -2. So you really want to make sure you remember those. So I originally get Ca2S2, but I have to simplify it. So if you can simplify it, it is obligatory to simplify it. So it's just CaS. Now for sodium phosphide. Sulfur's common charge is +1. Phosphorus's common charge is -3. So it's Na3P. I don't have to write the 1. So Na3P. I've got potassium fluoride. So when I crisscross it, it's just 1 and 1, so it becomes Kf. And then strontium iodide. So strontium has a common charge of +2. Iodine's common charge is -1. Crisscross applesauce. Ignore the negatives when I do the crisscross applesauce. So just making sure that you really know all your common ion charges. A lot of students like to write it on the top of their periodic table. Feel free to do that. That is all for today's video, or for this video. Thank you so much for watching and have a great night.